Hi students, this is Madhu Dharmapuri. Welcome back to the Electrostatics lecture series. In this present video lecture, I am going to explain about equipotential surfaces. Very important concept in electrostatics, very important for entrance examinations. Equipotential surfaces. The word itself is giving you the answer. Equipotential surface. Equi means equal. Potential, equal potential surface. You can understand it. So it is a three-dimensional surface. It's a three-dimensional surface on which electrostatic potential is same at every point on it. It is a three-dimensional surface on which electrostatic potential is same at every point on it. I've written that also. Equipotential surface is a three-dimensional surface on which electric potential V is same at every point on it. If V is same at every point on a surface, then we say it is equipotential surface. Very simple. And there are some important characteristics of this equipotential surface. Characteristics of equipotential surfaces. Characteristics of equipotential surfaces. The first point is, the first characteristics is potential difference, means electrostatic potential difference. Okay, potential difference between any 2 points, on this surface. This surface means equipotential surface is 0. Why potential difference is 0? Because potential everywhere is same. If potential everywhere is same, what? The difference between potential will be 0. It is very clear from the definition. Right? The second characteristic is that if a Q0 test charge, you can say if a test charge Q0 is moved on this surface, electric potential energy U, which is equal to Q0 V, because V equal to U by Q0, remains constant. If a test charge Q0 is moved on this surface, then electric potential energy remains constant. Means what? See, when Q0 test charge is moved on the surface, we have to perform some work. For example, anywhere, not on this surface. That work is called electrostatic potential energy. Actually, what is electrostatic potential energy? The work done in moving a charge from one place to another place is potential energy. One configuration to another configuration. We know that U is Q0 V. And this remains constant because V is constant. See, U is equal to Q0 V. We know that V is constant. V is same everywhere on this surface. Since V is constant, U is constant. So U remains constant. Potential energy remains constant on the equipotential surface. And from this we can write another characteristics that no work is done by electrostatic force electric force or electrostatic force in moving a test charge Q0 on this surface. No work is done by electric force in moving a test charge Q0 on this surface. What does this mean? This is clear from second characteristic. See, second characteristic is saying potential energy remains constant. Potential energy is not changing. If potential energy is not changing, then there is no work done by electric force. See, what is potential energy? Potential energy is actually stored when work is done. When work is done, that work is stored in the form of potential energy. Then potential energy, if work is done, potential energy should increase or decrease based on which direction the charge is moved. But electric potential energy is not changing, then there is no work done by electric force. See, whenever there is a work done, then electric potential will increase or decrease depending on the direction of the movement of the charge. If electric potential is not, potential energy is not changing, remains constant, for example, then what is the meaning of work done? There is no meaning for that. So no work is done by electric force in moving a test charge Q0 on this surface. Right? So everything is coming from definition. See, since V is same, potential difference is 0. Since V is same, electric potential energy is constant. Since electric potential energy is constant, then no work is done. Everything is coming from one to another. Right? Interlinked. Now you will see the next fourth characteristic. Number 4 is equipotential surfaces do not intersect each other. Do not intersect each other because, or if they intersect, then at that intersection point, electric potential will have more than one value. Which is not acceptable. Equipotential surfaces do not intersect each other. That is, if they intersect, they do not intersect each other is a characteristic. If they intersect, then at that intersection point, electric potential will have more than one value, which is not acceptable. See, what is equipotential surface? Electric potential should be same. Then electric potential will have, you can say, instead of more than one value, you can say will have different values. Will have different values at that point. which is not acceptable. Which is not acceptable. Right? So now we will see the fifth characteristic. Very important characteristics which can be drawn from the third characteristic. So that is why I am keeping it here. That is why I am keeping it here. Number 5. Since no work is done in moving Q naught from one point, in moving Q naught on surface, electric field must be perpendicular to the surface. That is, force equal to Q naught E equal to force must be perpendicular to distance or displacement, you can say displacement, perpendicular to displacement of charge Q naught on surface. No work is done. From 3 we know that no work is done in moving Q naught on surface. Then if no work is done, what we get from that point is electric field must be perpendicular to the surface, that is force must be perpendicular to the displacement of charge Q naught on the surface, that is F E perpendicular to dr. If Fe is perpendicular to dr, then F dot dr is F dot cos 90, F dr cos 90, which is 0, that is work done is 0. See, We is equal to Fe dot dr is equal to Fe dr cos 90 is equal to 0. Work done 0 means this. If this is 0, then Fe must be perpendicular to dr. If Fe must be perpendicular to dr, then electric field must be perpendicular to the surface because dr is on the surface. See, where Q naught is moving on the surface. That means displacement is along the surface. Then if displacement is along the surface, then force must be perpendicular to the surface. Then if force is perpendicular to the surface, that is electric field is perpendicular to surface actually. So electric field must be perpendicular to the surface. Right? Equipotential surface and electric field line is always perpendicular. That is this point number 5. Right? So from point number 5, we can write that we can draw that very important drawing. From that drawing also we can understand that electric field line is always perpendicular to equipotential surface. Let me draw it. So for positive charge, for example, if this is positive charge, and we know that electric field is always away from it. And equipotential surface should be perpendicular to this. So these dotted lines are equipotential surfaces, right? For example, if this is some 40 volt, this will be some 30 volt, this will be some 20 volt. This is electric field direction. So as you go away from the point charge Q, electric potential value will decrease, and on everywhere on this surface it is 40 volt, everywhere on this surface is 30 volt, and everywhere on this surface is 20 volt. This is equipotential surface, this is equipotential surface, this is equipotential surface, right? And we can also draw it for minus Q. For minus Q, the electric field lines are like this. Right? And the equipotential surfaces are like this is 1, this is 2. You can have any number based on the magnitude of charge. Right? So for this it will be, if this is 40 volt, this is 30 volt, this is 20 volt. And this is 40 volt, this is 20 volt, and this is 20 volt. And one more important point here we can write is, for point charge or spherical charge distribution, equipotential surfaces are concentric spheres. See, this is concentric spheres only, these are, because equipotential surface is 3D surface, remember, right? For line of charge distribution, linear charge distribution, you can say linear charge distribution or cylindrical, you can say. Equipotential surfaces are concentric cylinders. Concentric cylinders. And remember, electric field lines are always perpendicular to the equipotential surface. Right? Electric field lines are always perpendicular to the equipotential surfaces. Equipotential surfaces. This is very important. Because of this only, work done is zero. The electric potential energy is zero. Electric potential energy is constant. Electric potential difference is zero. All this, right? One from another. Since V is constant, U is constant, W is zero. But since W is zero, U is constant, and potential difference is zero. So this is how you have to analyze, right? And for uniform electric field, for example, right? So this is done. Okay. So in this case, it is actual electric field direction. This side, towards this side. Okay. So for uniform electric field, what is uniform electric field? This is true always. For uniform electric field, It's true for any type, non-uniform or uniform. For uniform electric field is same, and direction of electric field is also same everywhere, right? If this is uniform electric field, in uniform electric field, right? So if this is electric field direction, then equipotential surfaces should be like this, perpendicular to this. These are equipotential surfaces, right? And if this is 40 volt, this should be 30, this should be 20, this should be 10, because electric field lines always flow from higher potential to lower potential. Remember this point. Electric field lines flowing from this side to that side. So they have to flow from higher potential to lower potential. So this should be 40, 30, 20, 10 decreasing order. And remember, electric field direction is this way, and this equipotential surfaces should be perpendicular to that, right? So these are equipotential surfaces, vertical lines. Very important, right? So these are the characteristics of equipotential surfaces. Equipotential surface is a 3D surface on which electric potential is same at every point on it, and electric potential difference is zero between any 2 points on this surface. Electric potential energy remains constant when the charge Q0 is test charge Q0 is moved on this surface, and no work is done in moving a charge Q0, test charge Q0, from one point to another point on this surface, and they do not intersect each other. The two equipotential surfaces do not intersect each other. If they do intersect at that particular point, two potential values will be there if two intersect, which is not acceptable, because equipotential surface is a surface at every point on it is electric potential is same. If they do intersect, you will have different electric potentials at that particular point, which is not acceptable according to the definition. And since no work is done in moving a charge Q0 on the surface from one point to another point, then the force must be perpendicular to the displacement of the charge. Force must be perpendicular to the displacement means electric field line is perpendicular to the surface, because the displacement of the charge is along the surface, on the surface. So that is the reason electric field lines are always perpendicular to the equipotential surfaces. And we have drawn equipotential surfaces for point charges plus Q and minus Q, and equipotential surfaces are always perpendicular to electric field lines. For point charge and spherical charge distribution, equipotential surfaces are spherical concentric spheres. For linear charge distribution, equipotential surfaces are in concentric cylinders. And we have also seen the equipotential surfaces for uniform electric field. If electric field direction is this way, and equipotential surface should be perpendicular to it, and the electric field lines always flow from higher potential to lower potential, and hence this equipotential surface is 40 volt, 30 volt, 20 volt, 10 volt in decreasing order. That means everywhere on this equipotential surface, electric potential value is 40. Everywhere on this equipotential surface, electric potential is 30. So like that. Okay, very important concept. Hope you have understood. If you have any doubts regarding this lecture, you can put your doubts under the comment section. Thank you very much.